Hey everyone, and welcome back to the next part in our Mario Clone tutorial series. I am Chris, and we are going to continue working on our player script today. And what we're going to do here is we're going to add some restrictions to our player. So if you'll remember from the last tutorial, we added some movement so that the player could walk left and right, but he was able to walk through pretty much anything. So we don't want that in our platformer because that just makes the game way too easy and not a whole lot of fun. So let's make some restrictions for the player. And the way that we're going to do that is I'm going to introduce you guys to what's called raycasting. And raycasting basically is just how it sounds. We're casting a ray from the player, and what's going to happen is that ray is going to basically shoot out of the player a point that we define on the player to a target length. And if that ray at the end of it is colliding with anything in front of it or behind it or above it or below it, it'll return some information as to what it hit and how it hit it, and all kinds of other cool stuff that we're probably not going to use in this player or in this class, but we are going to get into that at some point. But for now, all we're going to do is we're going to raycast to check basically for walls left and right. And once we get a pretty good understanding of how all this stuff works, we're going to get more into raycasting for actually checking the floors for collisions there and the ceiling for collisions above the player. So let's go ahead and get started with that. So if you haven't already, go ahead and launch the player class in MonoDevelop. And we're going to go ahead and create a new method. And let's just put it at the bottom. And this method, we're actually going to return a vector 3, and the vector 3 that we're going to return is going to be our updated position, and that is, I'm going to actually explain that in just a minute what that's going to be. So we're going to check wall raise is what we're going to call it, and we're going to pass in a vector 3, and we'll call that position, and we're going to also pass in direction, because depending on the direction that the player is facing, we're going to need to do raycasting either to the left or to the right of the player. So we need to know that information. So to keep things a little more simple, we're going to create some origin points for our rays. And we're creating not just one ray from the player, but 3 rays. So one is going to be at his feet, one is going to be at around his head, and one is going to be at around the midsection of his body. Because if you try to think about this in another way, you'll see that like there are different height obstacles throughout the course. So you've got like the enemy, which is really only 1 unit high. Then you've got a small pipe, which is like 2 units high, and a larger pipe, which is like 3 units high. If you've got only one raycast coming off the player, and it's in the middle, then that raycast will never hit the enemy because it's too high, so that collision will never register, and our player will never die because he'll just be able to run through all the enemies. So we're creating additional rays so that there can be additional information sent back to us. So what we're going to do is we're going to go ahead and create the positions for those rays, and those can just be vector 2s. Okay, so we're going to create an origin top, and that's going to be a new vector 2, and we're going to take the position.x that was passed in. We're going to add the direction and multiply that by 0.4f, and that's a value that that I picked to actually. You know what? I'm going to explain that in just a minute. Let me write this first. Then the y position is going to be the position plus 1, and we're going to subtract 0.2f. Okay, so this is going to actually give us a position for our array, an origin position. Okay, so this is going to be for the top. All right, so if you look at the x origin, okay, we're going to take the x position of the player, which is actually in the center of the player. Then we're going to add direction, which is either going to be 1 or -1 based on his scale of the direction that he's facing. So if he's facing right, we're going to add 1 times 0.4f. So his position x plus 0.4f actually is going to equal where the ray begins at on his on the top. Okay, so that on the x position, the horizontal position, and 0.4. All right. So we're taking we're taking the direction, which if he's going right is 1, and we're multiplying that times 0.4, which is basically the player is 1 unit wide. Okay, so we're going to inset the ray by 0.1 by using 0.4 because we're getting the position.x, which is the center of the player. We're adding 0.4 to that, so the ray's origin on the x-axis is 0.1 inside of the player actually, so it's not like completely on the outside edge. And what we do for the y position, the player's actually 2 units high, so we're getting the center, which is 1. So we're adding the we're adding 1 to the y position, and we're subtracting 0.2f. And the reason that we're doing this is because we need to inset that ray also from the top, just a little bit into to below his head, because once we raycast from the top to see if there are any collisions on the top, if we also raycast directly from the top of his head, then we may have collisions when there really aren't any. It's kind of hard to explain, but we'll get to that. Let's go ahead and create the next 2 origins. So we've got origin top, now we'll do origin middle, and new vector 2. And for the x position, it's going to be basically the very same thing that we've just done. Okay. And then for the y position, all we're going to do is position.y, actually because, yeah, just position.y, because we're in the center. And then we're going to create the last position, which is origin bottom, new vector 2, position.x plus direction times 0.4, and we're going to do position y minus 1f plus 0.2f, because also we want to inset we want to inset our bottom ray just like we've insetted our top ray. Okay, so these are going to go in either the right or the left direction. So to create a raycast, we use the physics 2D class. There's also a raycast for 3D, which uses just the physics class, but for this we're going to use physics 2D. And our physics 2D raycast actually has a return value, and what it returns is a raycast hit 2D object, which contains all the hit information, which we're going to get into later. So for now, let's go ahead and create a raycast 2D variable, and we'll call it wall top. And we're going to use physics 2D .raycast, and we're going to pass in origin top as the origin, and the direction is going to be a new vector 2, and we're going to pass in direction on the x on the x coordinate of our vector 2, and 0 for the y. And then for our distance, we're actually going to use the player's velocity, the player's x velocity, and multiply that times time that delta time. And there's actually one thing that we need to specify here, and that is the layer mask, which we haven't created yet. And layer masks is actually something else that you guys are going to get introduced to here. And what basically those are you can put game objects on specific layers. So like if you've got a layer named player, you want the player to be on that, and a layer named platforms, you can put the platforms on that. And what'll happen is with each layer, you can specify what layer should be able to collide with other layers. So like if you want to make sure that the player doesn't collide with its own layer, like with its own self, then you would put a player on its own layer and then set it up in Unity so that the player layer doesn't collide with the player layer. And then like if you don't want the player to interact with anything like I don't know, well, I guess there's nothing that you don't want the player to interact with, but there are other things that you don't want to interact with other things. And that's how you would do that. You would create layer masks. For our case, we want to create a layer mask for our platforms and our walls so that we can say that, okay, well, we want to collide with those, right? So let's create a let's see, public layer mask, and let's call this wall mask. Okay. And then we're just simply going to pass that in here, wall mask. Okay. All right. So that is our raycast for our top array. So now we're going to create two more for the middle. Wall middle. This is physics 2D. Raycast, origin, middle, new, vector 2, direction, 0, velocity, at x, it's time at delta time, and wall mask. Okay, and one more. Raycast at 2D, wall bottom, physics 2D, dot raycast, origin bottom, new, vector 2, direction, 0, then velocity at x, there's time that delta time, and passing in the wall mask once more. Okay. All right, just want to mention real quick that these raycasts, we could have actually added these to an array, and we could have added a method to dynamically position those based on the height of the player and maybe amount of padding on top and bottom. And we could have just created a for loop to iterate over the array and check all of the raycasts to get hit objects back. But I didn't want to add any more complexity to this code before you guys actually understood what the raycasts do and how they work. So for now, this is the simplest way to do it. It's not the quickest or most optimized way or elegant way to do it, but it's one way to do it and it works. So now we want to check each of our hit objects to see if they actually contain a collider. Because when a raycast collides, it creates a collider object within the hit object. So the way we do that is we use an if statement, and we're going to check if walltop doesn't equal, or sorry, walltop.collider doesn't equal null, or wallmiddle.collider doesn't equal null, or wallbottom.collider doesn't equal null. Okay, so basically if any one of these three returns a collider, or if they all return colliders, or either one or the other returns a collider, then we know that the ray collided with something. So because we want our player not to be able to traverse through walls or anything like that, we know right away that if our raycast from our player that is being cast right or left, if that collides with anything at all whatsoever, we don't want our player to be able to continue to move into that direction. So what we need to do is we need to update our reference position variable, the x, and we need to decrement its position by its velocity dot x times time dot delta time, which is the position that it was at before it tried to move, where our collider says it can't move to. And we're going to multiply that by the direction. And then we're simply going to, at the end of all this, return the position for our vector. For our, what we're going to do is we're actually going to call this check wall raise in our update player position method. Okay, so in our update player position method, if we're walking, okay, while we're walking, we want to check if we're colliding with anything. So this is what this method will be for. It's actually going to check continuously to see if we're colliding with anything. It's going to return this position. And if we are colliding with something, okay, so we're multiplying the velocity times time dot delta time, and then we're also multiplying it by the direction that we passed in. So if you'll remember, that direction was either 1 or -1 depending on the scale of the player, which is dependent on which direction the player is moving. So if he's moving to the right, his direction or his scale is 1, so that means his direction is 1. So we're multiplying by 1. So let's say velocity equals 7, and for the sake of this, we're going to just leave out time dot delta time. We're going to multiply 7 times direction, which right now is 1, so 7 times 1 is 7. And we're going to decrement our current position by 7. So if we were walking right, our new position would equal position.x, would equal our current position minus 7, okay? So if we were walking left, our direction would have been passed as a -1. We would have multiplied -1 times 7, and we would have gotten -7, and we would have decremented -7 from our position.x, and that would have resulted in a +7 move towards the right. Okay, so that would happen if we were to collide with any of the walls. We would get that position back in our walking if statement up here once we actually call the method. What would happen next is, after this whole bit gets called and we got our new position, instead of using this position, we use the new position here, and we update our transform.local position to the new calculated position. And since if nothing here collides, we pass back the original position we passed to begin with, we would then just use that position if we didn't collide with anything. So that we would actually just use, one of these two. All right, so let's go ahead and do this. Let's do position equals check wall raise, and we're going to pass in position and scale. Okay, and that's it. So now we got to do one more thing real quick, and that is to remember we created a new variable up here named layer mask, and that was for our Raycast. So we need to implement this, and we do this in Unity with the inspector. Okay, so we've got a problem here. Scale. Oh, here. We need to scale. We need scale.x. Can't just pass scale because we're only using a float. So scale.x is what we need. All right. So now we've got that fixed. Let's go back to Unity. And errors are gone. Perfect. So let's go to player, and here it's asking us what the wall mask is, And right now we've got nothing defined as the wall mask. And let's go ahead and make our wall mask the default layer, okay? Because all of these, the platforms, the walls, everything here is on the default layer. So all of these things are actually going to interact with the player. Except, of course, the enemy, which doesn't have a layer, and the player, which doesn't have a layer. So let's go ahead and create some new layers for those two items here. Let's create a player and an enemy layer. Okay. Now let's go to the player, and it's already set the player, and the enemy is set to enemy. Just to let you know, this normally doesn't happen automatically like this, and it's because when I created the Unity package, all of these assets were bundled together, and when I created a new project, because I didn't have the layers already created, it gave them blank layers, but as soon as the layers that they are supposed to be part of were created, it automatically assigned those. So that's good to know. We'll keep that. And then, so since we've got our layers all set, we've got the wall mask set to default. Now we should be able to move around left and right. No jumping yet, no gravity, but we should be able to collide with, at the very least, everything except for the enemy. Okay, so let's try that out. Let's click play. Here's our player moving around. And not colliding with the pipe, but he collided with that pipe. Why didn't he collide with the little pipe? Why? Okay. Does he collide with the bounds? Yes, he does. We can't test the other bounds because he can't go through the other pipe. For some reason, he can go through the first pipe. That's strange. Let's find out why. The pipe is on the default layer. There's no special tags. You guys see? You notice what's wrong here? The pipe doesn't seem to have a collider. So this might be a good time to mention that everything that the Raycast will collide with actually needs to have a collider. So the simplest collider is going to be the found in Physics 2D under Box Collider 2D. Okay. Now you'll see it created only a little square, and that's because this is actually an empty. The pipe short prefab is an empty parent that contains all of these tiles to make up the pipe. All these children game objects. So what we need to do is we need to resize this this collider to fit the entire pipe. So what we'll do here is we'll just go edit collider and drag it out until about here. Drag it up till about right here. And you can always round these values up because we know exactly that all these tiles are 32 by 32 and they're 1 unit. So we can always go 1.5 units. So 1.94 should actually be 2. 1.99 should be 2. 0.49 should be 0.5. And 0.47 can also be 0.5. So now we've got a perfect fit for our collider on a pipe. And now if we try to play this again, our player should be stopped. And he is. Okay, so he can't go on. He's done. And there is a very basic, very simple collision detection using Raycast. That's moving the player left and right. Next, we are probably going to get into some more complicated stuff like gravity for the player, which will include jumping, and which will also include raycasting to the ground to check and see whether the player is on the ground or not. So stay tuned for that, and we'll see you guys soon.